Hello there. Alright, welcome to video lecture 7 for chapter 7. Air masses, weather systems. We actually talked about some of this material earlier, so I'm not going to talk about things again to be too redundant. We haven't talked about this too much. Types of air masses, right? Well, we did talk about before how air masses, air movements are named. They're named from their source, from where they're coming from, right? So if you see these names, well, and you can see where they come from, right? And of course, they have the conditions that you would expect. Continental, tropical, well, it's coming through Mexico, so that's going to be hot and dry, right? Continental, Arctic, very cold and dry, right? Maritime, they're going to be more moist because they're coming over the ocean, right? So general things to remember. So when looking at storms, what causes a big storm, when you have a cold front, so this is a really good depiction here. You have cold air moving into an area of warmer air. Now what this does is it forces that warmer air up, and not only does it force it up, but then it forces it, to precipitate if it has humidity in it, which, being warmer it probably does. Excuse me. So this is why you get a big thunderstorm happening with a cold front. Like this, you've seen these before probably. Now when you have a warm front, which is when you have the warmer mass moving over a colder air mass, well, it's going to be less of a big storm, right? Because, well, the warm air basically doesn't have to fight to be over the cold air, right? Because it's warmer, and so these clouds and the humidity is more spread out. That warm air isn't being forced to be cold at such a large rate. So you could still have rain, but it's not going to be those huge thunderstorms. Again, looking at gradient for pressure, if the lines are closer together, that means you're going to have stronger winds. Let's see. These will be useful for when you're reading about weather and what kind of fronts are going on and whatnot. And this is a good depiction of development of a mid-latitude cyclone. How does this cold front, warm front thing happen? As you can see how through time the one system follows the other, right? And it creates at the end there a cyclone, a circular air mass. Excuse me. Another view, take some time to look at this. Well, one thing I want to point out on this, as far as looking at patterns, you can see the doldrums, right, near the equator, which are not big storms, but just kind of a constant, precipitation, but not big cyclonic storms. Yeah, I think these are pretty self-explanatory. Again, looking at, I don't know what the green is on this map. It's kind of not a good map as far as that goes. Maybe green means precipitation. That's kind of strange, but the important thing is looking at high pressure, low pressure, and what kind of fronts are involved. So spend a minute looking at this, and you can read about lightning. Some good definitions of the different types of thunderstorms. So convective thunderstorms are the most common in lower latitudes. You got the hot surface, and so the air rises up and has moisture with it, humidity, and as it rises it cools off, and so it rains, right? Orographic thunderstorms are the ones that are, on that side of a land barrier, such as a mountain. When it's forced to go up, it cools off, and you have a thunderstorm. Yeah, and we already discussed frontal thunderstorms. Here's some more depictions or definitions. Can't remember where I dug this photo out of North Dakota snowstorm, but that's a lot of snow. Tornadoes are the most violent storms on the face of the earth. I think that's a quiz question. Far more in the United States here. Oklahoma and Kansas, they're called Tornado Alley. We'll talk more about that later. So a tornado is a small but intense cyclonic storm with very low pressure with violent updrafts and converging winds of enormous contrast. It looks big, but if you think about it compared to other storms and air masses and other cyclones, a tornado is pretty small compared to that. These are more photos I got offline. These are some storm chasers, people who help monitor storms, but also like danger, I guess. Yeah, read about this stuff. So using Doppler radar, the red lines are squall lines. If you remember what those are the lines of those storms, right, at the edge of fronts. And this is a good example of how fronts aren't as specific and cut and dry as they kind of look on maps and charts. As you can see, this front, it's kind of a little over here, a little over there, a little over here, but you can see a general trend. So Tornado Alley, well, right there. Right. The highest average number of tornadoes, right there. And there are different seasons for the peak of tornado activity. As you can see here in Minnesota, we get ours a little bit later in the year. And you go and read about this intensity scale. Easterly wave. This is important to know because storm surges often cause more damage than the storms themselves, the surge of water. Now this easterly wave here, it's a weak tropical disturbance, and it's a low pressure region. Now remember, low pressure, what does that mean? Warm temperature, cold temperature, low pressure, right? That means warm. So you got a warm spot there in the ocean. It might develop into something bigger, or it might not. We talked about hurricanes already quite a bit. Hurricane Katrina again. So yeah, as I was mentioning, the storm surges, right? That, well, that storm is pulling up that water with it, and when it comes ashore, that storm surge, that higher elevation of water that comes over the land, like cause a huge amount of damage. Again. Some common hurricane paths. They're also called typhoons in large parts of Asia, but they mean basically the same thing. As you can see, that similar hurricane path track, right, that we've seen again and again. Again, that similar track that storm goes through. All right, that's it for this lecture.